my screen. Yes. A flower means yes or it means you remind me of. If you can hear my voice, see my screen, type yes. Otherwise, I can't get a clear signal. Yes, very good. We need a yes. Now flowers. Flower now. I don't know the meaning of flowers. So it's good because we are getting somewhere. With now is which week? I think we still have 3 weeks left. So time flies. Time flies. You only have 3 weeks left. If I remember correctly, hopefully I don't remember wrong. I think I remember correctly. We only have 3 weeks left. So it means that hopefully this week we can finish this chapter, and the next week we can have another chapter. Then at least we can have 3 chapters. So sounds reasonable. 32 credits for 3 chapters. Sounds reasonable. And the last one, the last bit I intend to do is about the GPS bit. GPS, because we pretty much finished the tape. The distance measuring is about tape. And angle measuring is pretty much the distance measuring. Sometimes some machine they have to measure angle first in order to get distance. So angle measurement probably you don't have to spend time on angle measurement. It's pretty much the same. You have to do all the correction, correct this, correct that, correct angle, and probably it's easier because you don't have something called slope or anything. So in comparison, probably angle measurement is easier. So we probably, and we talk about the tape, measuring the distance. We talk about tape, and we also talk about the EDM, electromagnetic device measurement. So all these are the basic one. And this week, hopefully, we can finish the theory about the EDM bit. For the tape bit, how to do the taping bit and do the correction and error bit. You already know how to do this. And for the EDM bit, we need some theory. And for the measurement itself, it's not too hard. And you don't have to do a lot of correction as well. You don't have to do a lot of correction as well. But to begin with, let's review some of the trigonometry, because today we are going to keep on talking about the subtense bar and also about the EDM as well. So we have to talk about the trigonometry. Since there are some people who haven't come in, so maybe it's a good idea to start with some basic one. So trigonometry on the other hand, we'll keep on waiting for other people as well. So I don't know, getting low. We are going to finish this course, and the fewer people come in. Does that mean I don't teach you well or what? Or you are not interested in this course? But anyway, it's better to participate, and then you know what you want to do, and know everything as well. So otherwise, we are going to finish this course, and then you are going to come back again. So it's not a good idea. So let's take a look at the trigonometry. So trigonometry, you all already learned trigonometry bit quite a long time ago. So we don't really have to go through every bit of them. We just focus on some of them, and then you can have some idea. Then we'll come to our measurement bit, because we focus on measurement. Trigonometry just remind you some of the basic knowledge. So take a look at trigonometry. You basically have two kind of measurement. One is called, in the 3, one is called degree radian, and the other one is called gradient. So in principle, people use degree and the radian all the time. So this is basically about the length of the arc, we call the inclined angle, in comparison to the arc, and you can have it just depends on the how you. This is more like the angle itself, 360 degree, more like, and this one is considered about the arc, but it's not really the arc. It's the ratio between ratio of the arc over the length of arc over the length of a radian. So these are radius. So this is the ratio between the arc of the length and also the. Let me see if I can plot something over here. This is a very important concept. Otherwise, you might think it's a length itself. It seems like sometimes it doesn't work. Okay, just to let you know, this is the ratio, the arc of the length of the arc and over the length of the radius, and you get it's called this is a radius. So this is a ratio, and this will be kept fixed as long as you can correspondent to the. I get idea. I have other ways to do this. This is the one I found yesterday. So we can write something over here. I bet in YouTube some of them online teaching they use this one as well. So basically, this is a very good concept because most of the people they don't have a clear idea what does radian mean. They probably heard about radian, but they have no idea about radian at all. So this. It's easier to do this one easier, right? And then probably easier. Okay, so previously in your high school, in your senior high school or something, so you always use like the angle over here, right? So this is the angle. So everything divide is 360 degree. So we see the ratio between this one. So this is 30 degree. 30 degree. Okay, so you already divide the 360 degree every bit, and so you count how many units. So it's 30 units of 1 degree, so 30 degree. And so this is what you did. So how about this one? This one basically is the length of this one. The length of S1. We call this the length of. It's a length. You can strengthen this one. Last time we mentioned this one as well. You can strengthen this one, and it become the. You can measure this one. If you strengthen this one, you can measure this one as well. So because it's a curved line, it's hard to measure. But once you strengthen it, you can take this. These two are the same length. If you elongate this bit, it become like this one. Okay, and this is the radius, the length of the radius. Okay, so this one indeed this one. Yeah. This one indeed the length we define this one. We define this one. We define this one. This angle to be S divided by R. For example, if you this one let's say this one for example, if this length is 4. Let's say the 4, and this is the length 3. Then the angle, the radius of this one, it will be 4 over 3. 4 over 3. Easy. But how can this one be? Because I might have radius longer. My radius become longer now. Suppose my radius become like this one, elongated by this bit. Elongate this bit to this long, and I also elongate this bit to this long. And how about this one? So now you have another one. This is your another arc. Okay, so suppose elongate this one to be 5. The radius to be 5. I don't know how to get rid of only this number. Every time I get rid of everything. So I'm afraid to get rid of everything. So use it over here. No. Anyway, let's click this one. Okay. So the length of this one is 5. Okay, the length of this one is 5. And this one is 3. Okay, this one is 3. And indeed, it's a bit like a triangle. A bit like a triangle. If you look at this one is a bit like a triangle. See, if you trigonometry here, a bit like a triangle. This is triangle. So if this is 3, this is 5, and this is 4. By the trigonometry, indeed, this triangle is similar to this triangle. This triangle is similar to. So what does it mean? This number, suppose this is x. So 3, 4, the ratio between 3 and 4 equals the ratio between 5 and x. Okay, so you can sub. In this case, you can sub the solution of x. What's the number of x? X will be 20 over 3. So it's 20 over 3. So the ratio between this one, 3, for this length, the length of this one over this one will be the same like the length of this one over this one. And this triangle property also have the same property for the arc B as well, for the circle B as well. So if this is 4, this also be the 20 over 3. They have the same property as well. So what does it mean? This angle, the ratio, if you take the ratio, this is 4 over 3. This one, if you take this one as an angle, they always be the same, independent of the radius you choose, and independent of the arc, the length of arc. Once the radius is decided, then this one will be also decided as well. Automatically, this will be decided. So once you have a radius, this one will be decided. And the ratio always be kept 4 over 3. No matter, you can keep on elongate your radius. If you say I want to keep on elongate my radius over here, it will be the same. You can elongate the ratio between this one and this one always be kept 4 over 3. So this is a good one. This is a good one. It means they are independent of the radius. So this number can be kept as just a concept of this angle. Concept of this angle. All right. So this is just to let you know what the mean of a radius. Okay. Let's come to the next one. This is a very very good one. You can hardly find a teacher who explain this one to you in this way. So it's a good one. Next time you know the meaning of a radius very well. Okay, let's continue. So, of course, you design you know how to define the sine theta, cosine theta is hypotenuse. Hypotenuse is the one, is the one over the this is over basic one. I don't know why I should tell you all this basic one. Maybe I'm afraid you still don't know this basic one. Okay, so this is a triangle. So this is called, the length of this one is called hypotenuse. Okay, this is suppose this is your theta. Suppose this is your theta. Then this one we will call adjacent side because of the theta. This we will call the opposite side of the theta, and this we call hypotenuse. Just let you know. Okay, so you can design sine, cosine, tangent, all these all the basic one, all the basic. Okay, so and the relation, some relation over here. So we don't go through this video. You can check the Wikipedia as well, because I bet most of you can log into Wikipedia as well. And also, if you we don't need to talk about minus. Now all these relationship, basic relationship, you can take by yourself. Okay, so what I'm gonna look is this one. We call the is a particular name for this one. I think it's we used to call it the trigonometry identities. So this one sine, the General over here, over this here. So the sign of alpha plus beta will be this one. The sign of cosine will be this one. So this is the identical one. We'll use this one right after we finish this bit. We'll use this one. It's more than like what mentioned in the book. In the book, a lot of things are missing. So they don't care about mathematics. To be honest, they don't derive anything. They just write down something straight away. So they don't give you any proof, any derivation. It's not a good idea because you also need to know how it comes from as well. So we have to use this bit to do some derivation right after we finish this one. And we probably don't need cosine, tangent as well. So that's pretty much all we need. Very simple. So nothing complicated or fancy bit. We only need a small one. Of course, there are more like maybe at some point probably you can use this as well. It's called the double angle formula. Some of you already know this bit in high school. So double angle. From time to time we can use this bit as well, and we probably will use it as well. So stay tuned. And that's it. For the triple angle, normally it's very few people use up to triple. Normally it's like a double angle. For a triple angle, you can hardly find people have it. And half angle, from time to time in your surveying, you also need a half angle. So I can expect in your survey you have to use a lot of double angle formula. You have to use this bit as well, and also you have to use a lot of half angle formula. Indeed, they are pretty much the same. You just divide theta by something, it will become half. So it depends on how you read both of them. But it's better to memorize them individually. But in this course, you don't have to memorize anything. As long as you know how to operate it, will be good enough. We'll give you the formula if you have an exam. Okay, so you have a double angle, for the half angle over here, and you don't have to see the triple angle. I think very few people use triple angle in surveying. All right, and this bit, probably we don't use this bit very often, but there is one bit for the estimation. We have to use that bit as well. Let me take a look at estimation bit. Estimation for we call the Taylor's formula. Let me see, is that over here or not? Taylor's formula. Why do we need Taylor first? Taylor's one for the combination. You can combine cosine and sine wave, cosine wave and a sine wave into cosine wave or into sine wave. This is a technique as well. So two waves can be combined into one wave. So sine and cosine, they are highly correlated, related to each other. So you can correct. And why this one is important, because if you do the EDM from time to time, you'll find out some of the waves. They are the combination. They are the combination of sine cosine wave. So this is good, and then you can convert into cosine. Easier to do the plotting because this might be two waves. Look at two waves, and then you only have to use one wave to do the plotting. So it make things easier, life easier. So these are two waves. The additional two waves will become just one wave. So that's the reason people tend to use this bit easier outside. Okay, so also have we call phase shift. Last time we talked about something called phase shift as well. So phase basically just the angle. So we'll talk about that one as well. So today we'll talk about that one as well. And that's last bit. I intend to let you see the bit in the we call the Taylor's formula for the approximation, because sometimes you have to approximate something based on. Of course, if you have, I don't know whether in your course, maybe you don't, from time to time you have to have it's called complex exponential, or in particular we call Euler identity. From time to time you have to use this one as well, but depends. Most of the time you don't use them at all. Okay, so Taylor's formula. Let's keep on going until we find out Taylor's formula. We'll stop there and we come to our main one. Okay, so you can also compute pi, but to compute pi is not our paramount important speed. We're going to. Okay, so this is also important. For the we call the when x approximates 0, and this identity is very important. You use this one as well. And more than this one, you need more than this one. You also need this one as well. There is another one. Today we'll use that. Also use this one as well. All these are very basic trigonometry, but you got to know every bit of them, the basic one. Otherwise, you don't know how to do the calculation. So this is also this is tangent x. Tangent x. So this will also be 1 as well. So means sine x they run pretty much in the same speed. It means as they approximate 0, they pretty much run in the same speed. You run one step, I run one step, pretty much in the same speed. Also, so as tangent x and x, they pretty much run in the same speed as well. So we'll use this speed as well. Okay, let's continue. All right. So as for the this bit is for the differentiating this bit. Okay, and you also have Taylor. For the differentiate bit, we can also Taylor series. So I think Taylor series is coming. So sine, the differentiate of the sine will become cosine. Cosine will become minus sine. So remember these two. We'll use these two today as well. So remember these two as well. So let me keep on looking. We'll use some of trigonometry today, so that's the reason we have to mention a little bit of about this in case you forget it. All right, so unfortunately, there is no Taylor's formula for sine and cosine. So let me see if I can get over from here. I can get some of them. Okay, so okay, so now we can see sine is over here. Sine can be approximated by and this is important because normally we want to do approximation to some degree. You can, in particular, when surveying, how to if your x is ugly, you sine will approximate your x. For example, if your x it doesn't like a typical one, just like normally you have like a sine pi over 3 pi over 6 blah blah blah, this kind of good angle, but in real life you won't get this kind of angle. You'll get some very ugly one. What you get is like you'll get pretty much like 22 plus 1 2 5, something like this. Maybe you'll get this one, or maybe this one's too big, or maybe it's one. I can't get rid of it. Okay, so I get it, but this one means I keep on turning many times because one circle is only 6 point something. So this is what I want to say is that in particular, if you face some particular angle like sine, last time we talked about the slope, you are going to change it, and this slope might be 1.0211, something like this. So in this case, of course, this is in radians. So what's the number of this one? What's the number of this one? You say, sir, I have a calculator. I can use my calculator. Yeah, calculator, they calculate up to some point, accuracy up to some point. What if you really working in a company that the accuracy is really emphasized? So 1.012234, something like this. Of course, it is an extreme case. In this case, if you use your the calculator, normally it's hard to get a solution. Of course, for some good calculator, maybe they can back to and they can still find a solution. But most of the one, they just shut down. They don't work at all. So it means you really need some approximation approach to approximate this kind of weird angles, weird angles. So what I'm gonna do? Easy. Use Taylor's formula. Or here is called Taylor theory. Use this one. So Taylor theory based on Taylor's formula. So basically x is this one 1.02112234. You can have this one, and then you have a cube. This number cube divided by the factorial of 3. So on and so forth. You do all this bit, everything become easier. Everything, and then you can you can get the accuracy you like. So if you want to have higher accuracy, you add more. You have the next term is x raised to the power of 9 divided by factorial of 9, and so on and so forth. You keep on doing until you reach the accuracy you like, and then you can stop. And so this is good. You can, as a surveyor, you can control the accuracy you like, and do it by. And normally this can be easily done by computer. For even the calculator, they can do this bit, but to some bit, you raise to this higher power. For some simple calculator, it makes no difference between these two. So x raised power 5 and the x raised power 7, for them, for the calculator, pretty much the same. So they won't tell difference. So it's better to run by computer. In particular, you can write some programming. So unfortunately, in this term, we can't have a face-to-face conversation. Otherwise, I will teach you how to run have a programming, teach you some programming and do this bit. In other class, I told them how to do this, but this year is hard. Okay, so that's pretty much what we need. We probably, if we need anything else from trigonometry, we'll come back to this one. But I bet we have enough trigonometry knowledge for the moment. And this is for trigonometry function. You can do all the approximation based on here. You can do approximation. So the right hand side is a polynomial. Left hand side is a trigonometry. So this is a conversion between trigonometry function and the polynomial. You can convert this function into this function, and it's hard to do the calculation of this one, sine, cosine, but it's easy to do the polynomial bit. So that's the reason people tend to convert all the trigonometry to polynomial. But sometimes sine, cosine is much important. So in this case, we will convert things to sine, cosine rather than to polynomial. Because for polynomial, the looking is awful. But for sine, cosine, the looking is good because it's been constrained between 1 and -1. So it looks prettier than this one. This one will just keep on going and unbounded. So it depends on your purpose. Sometimes you convert sine, cosine wave, but sometimes you convert into the polynomials. But depends on your purpose. For calculation perspective or purpose, it's better to convert to this form, easier to do calculation. If you convert to sine or cosine, tangent this bit, it's very hard to do the calculation bit. But for the physical meaning or for the visualization, then trigonometry sounds is a better candidate than the polynomial. So it depends on your purpose. All right, pretty much the trigonometry you need to know for your surveying. We should have done this bit in our first class, but at that time we don't. I assume you already know the trigonometry, so I don't really in particular focus on this one. But now since we really have to use it, so that's the reason I had to remind you. And okay. Now let's come to, we still need two laws. One law is called the law of sines. In order to do this is very highly related to our geometry and also to our surveying as well. You probably have to use this law in your surveying all the time. So what does this law say? It's called sine law, the law of sines. This is a triangle. And the angle, this is A, means this one, this the angle, this is called A, B, C, the angles, A, B, C. And this is side, the opposite side to angle A is called, is the small a, and so on, so forth. B is a small b, C is small b. Okay, so what's the relation between the three sides and the three angles? They will be captured by this law. This law is called the law of sines. I bet in your high school, some of you already know how to derive this one. I skip the derivation because we are not talking about pure mathematics. Even if we are talking about pure mathematics, it's supposed to the range of high school, not in undergraduate. But as long as you know how to use it, I think it will be fine. Okay, so A is a side over the angle sine A. Sine A is this angle. So A over sine A equals B over sine B. Okay, so and C, this is, okay, you get all this. This is called science. This one is called law of science. And why does this one important to our survey? Take a look at one example. This example. Suppose now they already give you all the information. Suppose I don't know some of the information. Let me see if I can get some. Okay, suppose you get this one. In your measurement, measurement, you can get all this information. This is basically this is your machine. This is your for example, this is a total station or something, or maybe it's a talking about okay, this is a tachymeter. So the angle you measure is 35 degree, and according to some approach, or maybe you put your tachymeter over here again or something, move it again. Anyway, you get two angles. So in this case, you might wonder what's the distance between A, B. Is it easy? Suppose you already know, of course, you must have a knowledge of AC as well. Suppose you also get AC. So in this case, you can easily get a measurement. And how do I know AC? Normally, this is we call you can use a subtense bar. Last time we talked about subtense bar. So subtense bar is a fixed length of something. So you can ask one guy to hold a subtense bar over here to span over here. So suppose a subtense bar is 7 meters long. Indeed, most subtense bar is 1 meter long. Easier for people to hold. 7 meters probably is long and hard to carry. Normally, people don't use 7 meters long. Okay, so now comes to how to calculate the distance between this lever and also the A point, the object. Now we'll be use sine law. So and sine 185 degree, this one. C over this one. Will be the sine 35. 7 over sine 35. You get this one. And you can forget about this bit. This A over sine, it doesn't important. You only need just because you already know the number of sine 35. You also know the number of sine 105. Presumably you already know every number of sine value. Because you got a scientific calculator, so you can easily calculate all of them. There is no problem. So now from this one, you can easily get what's the length of C. C will be 11.8. Maybe it's a meter or something, but it doesn't matter. It's 11.8 something, some of the units. So this is just one example to let you know. If you know the law of science, then it's easier. You don't need too much information. All you need just a little bit information. Then you can get what you want. So that's the law of science. Okay, now let's come to another one. It's called the law of cosines. Today we will use all this bit trigonometry, basic one. The law of science, also the law of cosines. So it's important because you sometimes you don't have a EDM or something. Even you have an EDM, from time to time you still need some kind of calculation. It's inevitable. You cannot say, okay, I just shut my eye. I don't look at that. It's impossible. Okay, now they come to the law of cosines. Law of cosines. This one is called law of sines. Look at it. Sines means over here sine, sine B, sine C. So it's a law of sines. Now we have something called law of cosines. So what's the relation between the cosine and the size of the length of the size, the size of the triangle? Let's take a look. Suppose this is a triangle. This is a triangle, and this side is A, opposite to the this vertex. The vertex A is the size called capital A, small a. Okay, and then the capital B will be small b, and capital C will small c. C, A, B, C here means the side, the length of the side. Okay, so of course you can apply the law of sines, or just like this one, you can have these two over here, law of sines. But now we are going to use law of cosines. Sometimes this one doesn't work, and then from this one you can this one normally you need the information. What you need information is either two sides or two angles in order to get the other one. So and this one basically you need the two sides. So relation over here, c square, c is over here, c square. C square equals A square. A square is this side. A square plus B square minus 2AB times cosine gamma. Gamma is this one. Gamma is this one. So this is called the law of sines. This is called the law of sines, or sometimes called the cosine formula or cosine rule. People tend to call it law of sines. Law of sines. So this is important. And how about the other one? Suppose this one. This one, A square. A square or B square plus C square minus 2 times B times C, and cosine alpha. This one. See, and so is B as well. B will be opposite this one. So B square is the A square plus B plus C square minus 2AC times cosine beta. So this is the cosine laws. In particular case, in the Pythagorean theory, Pythagorean, suppose one of them is 90 degree, then everything will collapse, because 90 degree for the inclined angle will be 90 degree. It means cosine will be 0, so it will be collapsed to the square of one side. Normally is a hypotenuse. We just mentioned hypotenuse equals the adjacent side, the square, the length of the sides, adjacent. And then the opposite sides, also the square of the opposite side. So this when you collapse, it will become this one. But normally it doesn't collapse. It will just they'll be kept like this one. Okay. I think we pretty much have a good sound knowledge now. Now we can go back to our story. Let me briefly take a look at whether we need actual knowledge or not. Otherwise, we can go straight to lab B. So take this one for example. Take this one. There are some proof. You can do the proof. Proof in B. The proof itself as well. I don't want to go through the proof. It takes maybe 1 week to maybe not 1 week, maybe 2 times to finish that for the proof. But we don't need a proof. We just take a look how to use this bit. Okay, suppose I know the value of A. I know the value of B. I know the value of gamma, but I have no idea the distance between A and B, between these 2 points. What I'm gonna do now, easy. What I'm gonna do now is even simpler. What you're gonna do is suppose I set up a machine. Of course, my total station over here. I set up a machine over here. And then I look at one point. One point is something. Of course, this point is some point I already know the distance. I choose some point I already know distance over here. Of course, A and B is supposed to be the target you in order to measure. It's not a random one. It must be the AB distance you are interested in measuring AB distance. So you measure the distance between A and C. Give you B. There are some method you can do this one A and C again to get this one the length. Also do the same to CB. You get the length of CB. And suppose this is a tachymeters or some angle measurement. You can measure the angles between the inclined angles between these two sides. Suppose it's gamma. So in this case, AB can be easily recovered. You can calculate AB based on the cosine law. So cosine law, what cosine law says is the square, AB square equals A square plus B square minus 2AB times cosine gamma. Gamma already know, so cosine gamma can be calculated. There's no problem. A and B already know. So the AB will become the square root of what I just mentioned. So it will become like this one. C stands for AB because the angle, the vertex is a C. So the opposite side use a small c to represent this one. So you see, this is the one you get. All right, pretty much so. Let's go back. Pretty much so. Probably we have enough to now. Of course, the million billion about all this bit this kind of thing, but it's about trigonometry. Probably not really not related to this bit. Okay, let's go back to our book. We innovate about the laws, sine law, cosine law, and also the trigonometry. Let's come back. Come back to our book. This is our book. All right. Take a look at our book. At this one. Take a look at our book. Before I will take a look at this one, and then we'll come to the EDM. This one will be our last one in. But again, this is only for the tachymetric. There is one more single tachymeters. You can check. Basically, it's just like a machine. Your telescope. This all kind of thing. So it's nothing special. The tachymeters. Nowadays, people tend to put everything together, 3 in 1. So you can hardly find the tachymeters. Gradually, they phase out at some point, but need to know. Okay, so and you do the calculation. So take a look at your problem. Problem goes this way. You set up your machine over here. This is your machine. Your tachymeters over here. Your tachymeters over here. You see the machine itself is quite simple. You just have basically you have a telescope equipped, and you can see through the telescope. You can see the point, and you can measure the angle. Pretty much very plain one. So you need to some tools to assist this machine. Otherwise, you can't get what you want. Okay, so you set up machine, and HA is the ground. You set up machine. This one the leg of this machine must be put on the ground. So the ground, according to this one, HA basically means the mean sea level. It means above the sea level is HA, and this length is above the ground level. Above ground level, this is above the sea level. Sea level is over here. Is above the sea level, and then this is above the ground level. This is ground above ground level. So in total, the tachymeters in sea level will be in this one, this number. Let's call HR. In the book, it's called HR. It's height of maybe instrument. Height of instrument. The instrument means this one. Height of instrument. HA plus HI. I stands small I means instrument over here. Okay, so far so good. Now, take a look at the this machine. Your eye sees into this machine. So this one can be put evenly. If you put evenly, you keep on looking. Again, you'll see this point. You'll see this point. Then you can, of course, you can turn it a little bit, turn around a little bit. You can have some angle. You'll see this point and also this point. And this one, S S is the length between this point. Let's say this point is P, and this point is Q. So the PQ, the length of PQ is S. So S is also the length of the subtense bar. And last time I asked you guys to do this is called leveling stuff. Last time I asked you guys to do the calculation as well. So it shouldn't be the problem because you from this machine self, the machine self they'll tell you what's the angle between this one, this one, this one. So you get angle from this one. In this machine, you get angle. So there is no problem. And also you can have the length of this one. Why? Because this is what we call the subtense bar. Normally, it doesn't mean it have to be subtense bar. It can be anything as long as it's something you know the distance. That's the main point. You got to know the S beforehand. It doesn't matter it's a bar or not a bar. It can be just 2 points, and then you know the distance between that will serve our purpose. Anyway, so now suppose angle this one is theta. So by trigonometry, you can easily get what you want over here. I think it's some point over here is over here. This is the one I just mentioned. I replace that one with B, so it will become this one. So you can have a tangent hour equal this one, equal this one. So eventually you will get D. D is this one. From meters to the point you want to measure. So the horizontal one, horizontal distance is called D. D will be this one, B over 2 times cotangent. And approximately this one, according to our limitation, probably you can understand limitation. It will be approximate B over theta, B over theta. If you don't understand, you can ask me again. Yeah, this one based on the limit of tangent. I told you it just now is 1. Maybe it's still over here. You have to use this one. You have to use this one in order to get this one. Get this one. Okay, so approximately I will become this one. But now they have a calculator. You can calculate it straight away. You don't have to need approximation. No point. I can do the calculation. It's just sometimes you don't have a calculator in hand. And in this case, the simple way to do it is just B divided by theta, then become easier. Theta is this one. The whole bit is theta. This is a theta over 2. And the B is over here. B is over this. The length over this one is a B. So basically, the B divided by this one. Divided because if you look at get rid of 2. So this length divided by this one. Divided by this angle. So it's pretty much D. Indeed is a radius. If you look at the first one I told you guys, basically it's a radius. If you look at this one I told you, maybe it's gone. The previous one I told you. How do we define radius? It's the same idea. It's the same. Okay. I think so this is pretty much like a radius, right? Suppose that this is the circles. These are circles, and they're pretty much like radius. And this is the angle will be fixed. Okay, so it makes sense. Okay, let's take. I think it's a break time now. I think it's a break time. Oh, it's past break time. So let's take a few minutes break, and then when we come back, we'll go straight to not straight. We'll take a look at this bit because we have to measure the which bit, the very beginning one. We finish this bit as well. So 10 meters. We'll take a look at this bit. Our purpose will look at the length, in particular this one. What's the there's a relation between these two. We'll take a look at soon after the break. Okay, let's take how many minutes? 5 minutes, maybe 2 or 3 minutes. Okay, 5 minutes. So let's come back at 4:20. Now it's 20 already. 4:25. Okay, now it's 4:03. Okay. 3:20. Okay.